Welcome back. We are on lesson 3.8. We are renaming fractions and mixed numbers today. We're going to be able to rename mixed numbers and fractions greater than 1 by composing and breaking apart wholes. We're also going to be able to apply and extend our previous understandings of multiplication and division. Now, looking at the first objective, I want you to pay attention to, we're going to be creating mixed numbers and fractions by composing and breaking apart. So composing is putting together, and then breaking apart could also be said as decomposing. As usual, start off with a little warm up. So let's focus on the first one, and we're going to look at 11 halves. I want you to think, between which two whole numbers would this fraction be on a number line? We have 11 halves. And think also about how a fraction is like a division problem. Well, if we do 11 divided by 2, I know that 10 divided by 2 is 5. So if I'm doing 10 divided by 2, that's going to equal 5. I also know that 12 divided by 2, that's going to equal 6. So my 11 halves is going to be between 10 and 12. Taking that same thinking, let's do 17 thirds. Where would 17 thirds, between what two whole numbers would 17 thirds be on a number line? Think about what you know. Okay. Well, I know that 15 divided by 3 equals 5. Can we do 16 divided by 3? Can we do 17? Can we do 18? 18 divided by 3? I know 6 times 2 equals 12. 6 times 3 equals 18. So 18 thirds would be 6. So we've got 15 and 18. And so we know 17 thirds would be somewhere between 5 and 6. And finally, 26 fourths. What would that be? You can think about as division, and then think about where that would lie. I know 24 divided by 4 equals 6. I know 28 divided by 4 equals 7. So 26 fourths would be somewhere between 6 and 7. Notice we're using numbers that we know and understand. We're using those base numbers, kind of like that we did from lesson 7, those benchmarks. Our math message today is to write 21 fifths as a mixed number. Because today like we said, we're renaming fractions into mixed numbers, and we're renaming mixed numbers into fractions. So think about that division and what we've talked about in previous lessons, 21 fifths. And then, like we did yesterday, pause the video, explain to yourself, pretend you're talking to me, explain how you know that your mixed number is another name for 21 fifths. Remember, you can use those fraction circles that are on the Everyday Math website. You can draw a number line. You can create drawings to help you. You can do the division, whatever you need. Pause the video and come up with a solid answer. Okay, so now you can see my work. I did some pre-thinking here. I did 20 fifths equals 4 and 25 fifths equals 5. And you can see that I put 21 fifths in between those two. So then I looked at this one right here and I said, okay, 20 fifths, that's only 1/5 away. So I know that's going to be 4. with 1/5 left over. So that gave me my mixed number of 4 and 1/5. So some sample arguments for that, and I meant to take these away before, but we'll just go. Like we said, we can think of 21/5 as 21 divided by 5, and we know that that is 4 remainder 1, or 4 and 1/5. Another argument that's possible for this would be using 21 dark green fraction circle pieces to show 21/5. When you put the pieces into groups of 5, it makes holes. And so there are 4 whole circles with 1 piece left over. That's if you use those fraction circles. You would use the fifths. And counting up 21/5 from 0 on a number line is possible as well. And you know that each set of 5/5 makes 1 whole. So you circle the whole numbers. And then as you count up every 5, and then you should see that you only go up 1/5. And let's take a look at that actually. Here is the number line using the fifths. So you can see 5/5 is 1, 10/5 is 2, 15/5 is 3, 20/5 is 4, with 1/5 moved up. Okay. Can we think of another mixed number that's equivalent to 21/5? So we created 4 and 1/5, but are there any other mixed numbers that are equivalent to 21/5? Yeah, there is. You could do 1 and 16/5, because I want you to pay attention. We didn't say that creating these new names, you couldn't use an improper fraction with a whole number. It's just not what we usually do, but those are other names. Okay, you can show 21/5 with fraction circles using 21 green fifth pieces like we talked about. When you're putting those 5 pieces together, they make holes. So you could say I have 1 whole with 16 pieces left over, and saying 1 and 16/5. So today we're going to practice doing some of that. Here are the other names that you could do. You could do 1 and 16/5, 2 and 11/5, 3 and 6/5, 4 and 1/5, and 21/5. These are all equivalent names. They all mean the exact same thing. So naming a mixed number using the biggest whole number part is possible, can be useful for deciding which whole number it is closest to. This is what we are used to with mixed numbers, but these 3 are also equivalent names. So in later lessons, we're going to see how other names can be useful when we're adding and subtracting whole numbers. Because if you think about when we borrow, we may have to use one of those other names. But today we're going to practice just finding as many names as possible for fractions and mixed numbers without changing the denominator. So let's do another practice. What is another name for 3 and 2/3 that has a denominator of 3? So we're not changing the denominator. We're leaving it as 3. You should try that on your own. Pause the video if you need to. So a possible argument is drawing a picture of 3 and 2/3, then dividing one of those holes into thirds. And so you see here's our original 1, 2, 3 holes and 2/3. If we divide this one up into thirds, we can see that we have 2 holes and 1, 2, 3, 4, 5 thirds. So that is the same thing. We could keep this going. We could do some more with it. So, but when we renamed 3 and 2/3, did you think about grouping fraction parts into wholes like you did in the last example? Why or why not? Think about that for yourself. What other mixed number names for 3 and 2/3 can we find by breaking apart the wholes? So I'm going to come back to this picture here, and I'm going to show you. So we could split this one up into thirds, and so then we would create the name 1 and 1, 2, 3, 4, 5, 6, 7, 8 thirds. And then if we split this one up again, we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we'd have our 11 thirds. So for this one, we have 3 and 2/3, 2 and 5/3, 1 and 8/3, and 11 thirds. We have 4 different names for that without changing the denominator. So thinking about making wholes from fractional parts and breaking apart wholes into fractional parts are both methods of finding different names for fractions and mixed numbers. Putting 5/5 together to make a whole is like trading 5/5 for 1. This is a fair trade because 5/5 equals 1. So breaking a whole number into thirds is like trading one whole for 3/3. That's a fair trade because 3/3 equals 1. As long as the trades you are making are fair, you have not changed the value of the number. Checking whether a trade is fair is one way to make sure that the two names are equivalent. So just remember that when you put the same number of a numerator over the same number for the denominator, that's going to equal 1. Okay, so if we have 6 over 6, that equals 1. 8 over 8. 24 over 24. That equals 1. So that's a fair trade. And that's what we're doing. For example, if we did 3 and 2/3, if I take out, we see what the denominator is. If I take 3/3 and put it into my fraction, we have created 2, because I've taken 1 away from this, and 5/3. That's how we're able to do that. So we're going to do, I'm going to do a couple for you, and then you're going to do the rest for today. So let's take a look at number 1 together. It says find another name for 2 and 3/4. Show 2 3/4. Break apart one whole, so it's telling us one whole, into 4/4. So over here, I'm going to do my thinking. We have, I'm going to draw 2 holes, and I'm going to draw a third one, but show that I've only got 3/4. Okay, so there's 1, 2, 3, and we know that this whole thing is shaded. Apologize for my shading. I'll change the color here for my showing. So here I show I've got 1, 2, and 3/4. I want to break apart one of them into fourths. So I'm going to break this one into fourths here. So now I have 1, 2, 3, 4, 5, 6, 7, and 7/4. Okay. Let's take a look at what they've got here. 1 and 7/4. So you see that I traded 1 for 4/4. I can also write over here in my notes that 1 equals 4/4. So if I take 2 minus 1, we have 1 left over, but then I'm going to take 3/4 and add in my 4/4, which would give me 7/4. And I want to look at number 5. Again, you're filling in the missing whole number or a missing numerator. So for number 5, we've got 1 and 4/3. We're going to change it to 2 and something thirds. Okay, so I know my whole number is going to go up. That means this number right here, my fraction, is actually, the numerator is going to change. It's going to become smaller. I want to ask myself, what denominator are we working with? We're working with thirds. So I know 3/3 equals 1. So I took 3/3 out of 4/3. So this is going to be 1/3 because 4 minus 3 equals 1. So 1 and 4/3 is the same as 2 and 1/3. I would like you to pause the video and work on solving number 2, 3, 4, 6, 7, and then try number 8. Pause the video and then come back and we'll check our work. Okay, number 2, after you did any regrouping, you should have come up with the answer 4 2/3. So 14/3 equals 4 2/3. Number 3, 2 4/5 can be renamed as 1 9/5. And this is an example, so you might have multiple different ones, but 1 9/5 is an example because 1 whole is equal to 5/5. Number 4, 10/10 is equal to 1 whole. So a name you could get was 2 2/10. Again, these are just sample answers. You might have had something different, but hopefully if you came up with multiple answers, you can check to see if you understand how to get these. Number 6 should have been 3. The whole number would have been 3 for 3 7/5 equaling 4 2/5 because you put 5/5 back into this. Number 7, 2 9/2 equals 4 5 halves. And what we can see here is we actually had 2 to 4, so you took 4 halves out of 9 halves. So 9 minus 4 is 5. Mojo the monkey has 2 whole bananas and 5 half bananas. Write a mixed number to show how many bananas Mojo has. 2 whole and 5 halves. 2 5 halves. And the answer to B would be yes. If Mojo traded 4 of his bananas, he would have 4 whole bananas and 1 half banana. That's the same as Manny. And C, he has 9 half bananas because 9 divided by 2 is another name for 2 5 halves. So again, today all we were focusing on was creating new names for fractions using mixed numbers as well. And I want you to remember this parts that we talked about right here. These are all, we can have multiple equivalent names. We can use a whole number and a mixed number, or a whole number and an improper fraction to make our mixed numbers, because that's going to come in to help when we were adding and subtracting whole numbers in our future lessons.